Prime factorization. Prime factorization is that requires that you can identify whether a number is prime or composite. If you can't remember, maybe you should check out the presentation, prime or composite. Prime factorization is when you represent a number as the product, series multiplication, of a set of prime factors. So we're going to write a number as a series of items that are multiplied together where each of those items are prime. So we use what is called a prime factorization tree. So let's look for the prime factorization of 12. Initially, we need to find two numbers whose product is 12. We could use 2 times 6 or 3 times 4. Either one will work. Let's use the 2 and 6. We write it this way. 12. We break off 2 little arrows on the bottom, 2 little lines. Write 2 and 6. The 2 is prime, so we leave it alone. The 6 can be further factored as 2 times 3. And we write it this way. Now, this 2 and 3 are both prime, so we are done. Now we grab the numbers at the end of the stems. Those little lines are stems. So we have 2, 2, and a 3, or 2 squared times 3 to the first. So that is the prime factorization of 12. Let's do the same number 12 again, but this time let's choose the 3 and the 4 as opposed to the 2 and the 6. So in this case, we're going to use the 3 and the 4. The 3 is prime, so we leave it alone. The 4 can be further factored as 2 times 2. We write it this way. The 2 are prime, so we're done. And we grab the numbers at the end of the stems. So 3 times 2 times 2. Hey, that's the same answer. Let's try 75. You might realize, well, 75 is got ends in 5, so we can divide it by 5. So we get 5 times 15. The 5 is prime. 15 is not. So we further factor the 15 as 3 times 5. We grab the numbers at the end of the stems. 5 times 3 times 5, or 3 to the first times 5 squared. Or maybe you did it this way. You realize that 75 is 3/4, so you write it as 3 times 25. 3 is prime, 25 is not. We further break the 25 down as 5 times 5. Grab the numbers at the end of the stems. Wow, it's the same. Same result. It doesn't matter how you start. Start whichever is the easiest pair for you. If you saw that 75 was 3 times 25, you could start with that. If you didn't, you could say, well, 75 ended in 5, so I know 5 goes in there, and you could start with 5 times 15. Doesn't matter which way you start, you will end up with the same answer. Let's take a look at 16. 16 is 2 times 8. The 2 is prime, the 8 is not. 8 is 2 times 4. The 2 is prime, the 4 is not. We break the 4 down. Grab the numbers at the end of the stems, and we have 2 to the 4th. Or maybe you wanted to start this way. 16 is 4 times 4. And each of these 4s can be broken down into 2 times 2. Grab the numbers at the end of the stems, and we have the same answer. Again, it doesn't matter how you start, as long as you follow the rules. Just pick whatever pair is easiest for you. Take a look at 98. Well, I can say, well, 98 is even, so I'll divide by a 2, so it gives me 2 times 49. 49 is 7 times 7. Numbers at the end of the stems, 2 to the 1st times 7 squared. How about 360? We could do 2 times 180. 180 is 2 times 90. 90 is 2 times 45. 45 is 5 times 9. And the 9 is 3 times 3. So we grab the numbers at the end of the stems, and we have 2 cubed times 3 squared times 5 to the 1st. Now let's try it again with a different pair. Maybe we recognize that 360 is 36 times 10. I like to do this with numbers that end in 0. To pull out the 10 first. Starting off with bigger chunks, it makes it a little easier. 36 is 6 times 6. The 10 is 2 times 5. Each of the 6's needs to be broken down into 2 times 3. Grab the numbers at the end of the stems, and it's the same answer. 2 cubed, 3 squared, times 5 to the 1st. Look at all the different ways that we can do 60. 2 times 30. 30 is 2 times 15. 15 is 3 times 5. Or maybe 3 times 20. 20 is 2 times 10. And the 10 is 2 times 5. Or maybe you prefer 4 times 15. The 4 breaks down. The 15 breaks down. Or maybe 5 times 12. The 12 breaks down. The 4 breaks down. Or maybe just 6 times 10. So again, it doesn't matter which pair you start with. Start whichever one is easier for you to see. If it's prime, leave it alone. If it's not prime, break it down further. And the numbers you want are the ones at the end of the stems.